Welcome back, everybody. Today we are learning about writing proofs involving segment addition. Segment addition postulate is really just a formal name for something that you've already learned in Unit 1A. And here's what it says. It says, if points A, B, and C are collinear, then B is between A and C if and only if AB plus BC equals AC. So remember, this if and only if is abbreviated IFF. It means that it's a biconditional statement. So what that means is that if we look at the hypothesis and the conclusion, let's call them P and Q. The conditional is true, so P must imply Q. And also Q, the converse is true, Q must imply P. So both of these must be true since segment addition postulate we know is true. So it says if B is between A and C, then AB plus BC equals AC. And also, if AB plus BC equals AC, then we can conclude that B is between A and C. For both of these, you have to know ahead of time that points A, B, and C are collinear, which remember means they're all on the same line. So let's look at what this looks like in a diagram. If we have points A, B, and C all on the same line here, they're collinear, then we know that the length of AB plus the length of segment BC must add up together to be the length of segment AC if point B is between points A and C. Let's try an example with this. So this says, prove that if segment CE is congruent to segment FE and segment ED is congruent to segment EG, then segment CD is congruent to segment FG. Remember, the beginning part of the statement that goes with if, this part is called the hypothesis. This is what is given to you. So you're going to go ahead and write this down under the given information. The part of the statement that is the conclusion, the part with then, is called the hypothesis. This is what you're trying to prove. So go ahead and write that down under what you're trying to prove. Now let's look closely at what we are given and what we're trying to prove using the diagram. So we are given that segment CE is congruent to segment FE. So we're going to mark that in our picture. In addition, we know that segment ED is congruent to segment EG. So we'll go ahead and also mark that. We are trying to prove that segment CD, that's this whole segment here, is congruent to segment FG, this whole segment here. We don't want to mark anything for those in our diagram because the diagram you only want to mark up with the given information. You don't want to mark it with what you're trying to prove because that can be confusing with what you have so far. So to begin, we know that we always need to write down the given as the first statement, and the reason is just it's given to us. Now, if you're not really sure where to start, luckily, this one gives us a hint. It says, reason number 2, use the definition of congruent segments. Well, I know that the definition of congruent segments states that if two segments are congruent, then they have equal measure. So I'm going to go ahead and apply this definition to what I have here. Next, it says use segment addition postulate. So I'm going to go ahead and use segment addition postulate for segment FG first. So I know that FE plus EG would have to equal FG. And now I can use it for the other segment, CE plus ED must be equal to CD. The reason I knew that I should probably use it twice is because when I look at my given information, I need something that has to do with CD and something also that has to do with FG. So I knew that I would probably need both of these equations because one has CD, one has FG. All right, how am I going to get CD and FG congruent to each other? Well, it's, like I said, important to plan ahead in your proofs. And when I'm thinking ahead, I know that if I can get CD equal to FG, it will be very easy to say that they are congruent. So my goal here I want to try to somehow get CD equal to FG. Well, looking at what I have, I see that FE and CE, these are actually equal. I put that right here. I also know that EG and ED are equal based off of what I have in step 2. So if I can somehow get these two left sides to be the same, then I know that I'll be able to use transitive property or substitution somehow to get FG equal to CD. So let's work on getting these two equations to be the same on the left side. I'm just going to work with this first equation. I know that FE is equal to CE. That's what it says in step 2. So I'm going to substitute in CE for FE. In addition, I know that EG is equal to ED. That's what it says in step 2. So I'm going to plug in ED for EG in the equation. Finally, I need to leave equals FG, and I need to have a reason for this. So my reason is called substitution. And you may want to make a note to yourself that you substituted in CE for FE and also ED for EG. All right, the reason why we did this is because now our left sides of our equation look the same, while the right sides we have FG and CD, which is what we're trying to get equal to each other. If I know that CE plus ED must be equal to CD, which is what I have here, CE plus ED is equal to CD, I can go ahead and replace that in this equation. I know CE plus ED is equal to CD, so I can replace it. It's called substitution. Remember, substitution says if you know something is equal, you can replace it in any equation. So I basically substituted in CD for CE plus ED. Now I can leave the right side of my equation the same and keep it as FG. The reason I tried to keep CD on the left side is because I see that in my answer, CD is on the left side. However, if you did this problem a little differently and you ended up with FG equal to CD, it's not a big deal. You'll just have to add in a step where you use symmetric property of equality. I'm very close to what I need, except I need to say that the segments are congruent based on the definition of congruent segments. Once you have what you were trying to prove, you can end your proof in any way that you'd like. What's your favorite way to end the proof? On this one, I can use boom. That's Fifth Bell's favorite way to end a proof. All right, next, I would like you to try this practice problem here. Complete the proof below. There's already some steps given to you, but before you start this, there are some typos, so I just wanted to point them out. On step 3, there's a typo. It should say JK plus KL equals blank, and on step 6, it should say simplify instead of substitution. So pause and see if you can fill in the missing statements and reasons now. All right, let's go over this together. Let's first look at what we're given and what we're trying to prove. So we are given that JL is congruent to KM. That's a little difficult to mark, so I'm just going to do it like this. JL is congruent to KM. We are trying to prove that JK is congruent to segment LM. So the first step, they wrote down the given. Then the next step, they wrote JL equals KM. How do they know that JL is equal to KM? Based on the first statement. I need you to fill in that reason on your own. Next, it said on step 3, use segment addition postulate. So I'm looking at what I have so far. I have JK plus KL. So let's look at that. JK plus KL. That I know must be equal to the full segment JL. So I filled in JL here. Next, I have KL plus LM, so that's KL plus LM. Together, that would have to add up to the whole segment, the length of segment KM. So that's why I filled in KM here. So hopefully you got those filled in correctly. The next step is a little bit difficult. Let's go over this. So we have JK plus KL equals JL. But I know that JL is equal to KM. However, I know also that KM is equal to KL plus LM. So going from the very first statement to the very last statement, I don't know if this is the third or the fourth, but going from the beginning to the end, I know by transitive property or by substitution, however you want to look at this, that JK plus KL, this is the beginning, must be equal to the end, KL plus LM. So it's kind of like a little train there. On this equation, I notice that it has KL on both sides. Therefore, I could cancel it out by subtracting KL on both sides. Subtracting the same value on both sides is known as the subtraction property of equality. And since that cancels out, so KL cancels itself out on both sides, I would be left with just JK equals LM. So that's what I got for step 6 by simplifying. Finally, you didn't have to do anything for this, but to move from step 6 to step 7, if two segments have the same length, they must be congruent segments by the definition of congruence. And end your proof however you'd like. In 7th Bell, they like to end their proof with period. Finally, answer this reflection question, please. Explain why it's important to draw a diagram and label a diagram for every proof. Thank you.